Okay, I assume because I'm last that I have unlimited time and I can talk as long as I want. I appreciate that.
You,
So
you
I'm going to do that anyway, Chelly. So
okay.
we've already seen this definition, and it says here, if I can find it, yeah, without any mechanical consolidation. Now, I was on the committee when this definition was written, so I have to take responsibility for rewriting an erroneous definition to some degree. But this is the definition. If you vibrate SCC, is it still SCC? So is it self-consolidating if you vibrate it? Well, no, of course not. Actually, that's an April Fool's joke because of course it is. It's still self-consolidating concrete. If I'm placing 25-inch slump flows and I vibrate it, it's still self-consolidating concrete. You can't convince me otherwise. You can try. So if you're driving or in a self-driving car and you're behind the wheel and you take control of it to avoid a crash, is it still a self-driving car? I'll let you ponder that question. And by the way, if that's me in a self-driving car, I'm not going to be that relaxed. I don't like riding with people. I'm pretty sure I can't do a self-driving car. All right, so the rest of this is going to be a lot of pictures and some videos. I'll warn you when I get to the videos that there will be sound, so don't have your speakers too loud because you'll hear some vibration going on. I do have a lot of pictures. I'll be talking through the pictures and explaining a few things. So we'll get going. Okay, so this is from ACI 309, and it talks about consolidation of concrete. So a few things to note here, that using a vibrator, you should be a well-trained operator, right? That's obvious. You should be trained. I would say that's not the case in all situations, whether it's a ready-mix, precast, SCC or not. And that vibrator operator should have the ability to make sure that he's using that vibrator correctly so that he gets proper consolidation. And the key to proper consolidation, of course, is to have complete consolidation, but it's also to have it without segregation as noted here. So doesn't that apply to both self-consolidating concrete and regular slump concrete? I think it does. We see some more information about vibrators here. And then in many thin sections, especially in precast, external vibration should be the primary method of consolidation. I would agree with that. I think there's certain reasons or cases to use external vibration instead of internal vibration. We'll talk about that a little bit. This is the look you get from the foreman at the precast plant if you tell him he can't vibrate his concrete. This is an actual photo. No one was injured making this video or taking this picture. We just had a discussion. But that is the look you're going to get if that happens. So let's get talking about precast. So there's a lot of different things that are cast in precast. You have very simple things like traffic barriers. This would probably be placed without consolidation because there's very little reinforcement. They're typically not too worried about the surface finish. Manholes and catch basins. In my experience, this is about 50-50. Some plants will vibrate this, most of those with some external vibration, some will not. And it's not tied to necessarily the reinforcement or the form or even the slump flow. I think it's more about, as Joe alluded to, and I was happy to hear his presentation, is that a 25-inch slump flow with a very slow, creepy slump flow is a lot different than a 25-inch slump flow that gets there really quick. So the viscosity of those mixes plays a huge role in whether it's being vibrated or not. You have stairs, you have these planters and railings, and most of this, even placed with self-consolidating concrete, is going to be vibrated, typically externally. And again, it's not, in this case, not so much about the slump flow or viscosity. It's just about the fact that the manufacturer wants to get the definition as sharp as he can on these, and he's typically not worried about segregating this concrete. Modular prison cells. Now, this is an interesting story. These cells, first of all, they're very uncomfortable, but they do not place them vibration free. However, they went from doing about 15 to 20 minutes of vibration on these units when they were using 7 and 8 inch slump concrete to now they vibrate for about 20 seconds, all external vibration, but they need that external vibration to get the finish that they want and to make sure that these corners are completely closed in around these window inserts. So this is it's vibrated, it's placed at pretty high slump flows, again, 25 or more, and they still use some external vibration. Wet precast pipe is all over the place. You'll see some that use no vibration, some that use some vibration, some that use internal, some that use external, but it is all over the place. The septic tanks, utility vaults, again, pretty simple construction. And typically, if they're using self-consolidating concrete, they are not vibrating these. You do see it occasionally. Burial vaults, again, pretty simple. They like to get a good finish because they look good, but most are not willing to avoid using excessive form oil, so they still get bug holes. And they also will tend to vibrate this some, again, to get the very sharp edges on this. And these are placed typically at very high slump flows. Wall panels really depends. If it's a typical gray panel, it may not get vibrated, probably will not. If it's architecture, it will, and I have pictures of those. Box culverts, very similar to the manholes. Again, it's a bit 50-50. You get some vibration depending on the viscosity of the mix, not necessarily the slump flow of the mix. This is interesting. I have forgotten the name of the bridge in New York. These were cast in Virginia on the shore, and these huge sections were barged upriver to go into place on the bridge. This is a complete segment, and these are massive. This used self-consolidating concrete, but they did vibrate. So these were vibrated, high strength, really good finish, lots of rebar in these, as you might imagine. And frankly, I think these are the largest precast segments I've seen. So this was definitely vibrated. Bridge segments, again, pretty simple construction. For the most part, not vibrated. They're not too worried about the finish. These are going to get a topping after the fact. So all they need is enough slump flow to consolidate around the rebar, and it's not too heavily reinforced. So typically not consolidated, but not always. This is a U-beam, and I know the picture is not real clear on what the piece actually looks like, but again, large. And typically there's vibration, sometimes internal, sometimes external, and often both. And these are placed again at high slump flows. These types of panels are almost always vibrated, placed at very high slump flows. You have a brick insert face down in the form. You have colored concrete placed on top of it, and trying to get these really nice defined edges where the brick is. Again, this is, and I think I have some video in here of this actually being placed and vibrated. So again, it's definitely SCC. It's often very high slump flows, and it's almost always vibrated again to get the really clear definition around these inserts. This is just some more architectural stuff. This has obviously been sandblasted. And again, they want to make sure they get aggregate at the surface. Some of these are placed in 2 layers. I can't tell if this one was or not. Here you just have a brick pattern, and then there's just various precast columns or column facades here. And again, those are sandblasted. Almost all of this stuff gets vibrated. If I sound like I'm making an argument for yes, SCC can be vibrated, then you are correct. I am. Double T's, I know some precast plants will only do self-consolidating and will not vibrate. I know others that only do self-consolidating and always vibrate. There's 2 types of vibration typically that goes in here. I don't see a lot of external vibrators. I do see internal vibration in the T's as they're placing these. And typically what I see is that the T is filled first, both sides, and then they come back and start filling the top. So you'll see some vibration in the T's, and then for the top, it'll be a vibrating screed. And then most of these are rake finished, and they get a topping on top. Some are cast as finish, but these typically turn out a really nice finish, very few bug holes. And if they do have bug holes, it's usually concentrated somewhere where they've pushed up form roll. These pretty simple ledger beams, depending on the reinforcement, and this one is not too heavily reinforced, they likely will not be vibrated, but they could be. The beams here at the bottom, and if you look close, you'll see that there's just an enormous amount of strand, and I'm moving my pointer. Hopefully you can see that enormous amount of strand at the bottom of these. And what happens often is SEC is used. The concrete flows. They'll start at one end. Typically, concrete flows, but there's sometimes some honeycombing at this angle at the bottom, at the flange. And so what you'll see oftentimes is either an internal vibration, which is put down at the leading edge of the SCC as they're placing it, and to make sure that this area at the bottom gets consolidated around all of this strand. Or you'll see like a track vibrator on the outside, and they'll move it along as they're placing the concrete again to make sure that this area is void-free, honeycomb-free down in here. There's nothing worse than stripping this and having your strand exposed down at the bottom here. It's usually less reinforced at the top, but again, it's not wide open either. So a few of these you'll see without consolidation, and I'm sure everyone on here that's seen these placed can tell me whether that's done, and I could too. But most of these I see get some vibration. And this is just more pictures of the same. Some of these are bigger, different flange at the top, but again, most of these I see get vibrated. Some of these, and Shelly, this is interesting. Some DOTs require vibration. It's an interesting dynamic. Some DOTs, and I'm not going to name them, don't allow SCC. So they measure slump, but the slump might be 9.5 inches. So the slump flow is in the 22, 23 range, but they still require it to be vibrated. Again, it's kind of interesting. Piling, often these are not vibrated. Again, pretty simple construction. It's just concrete that goes in, and there's not a lot of depth or volume here. So most of the time I see that these are not vibrated. This is interesting. These are unique. These are spun poles, and there's quite a bit of strand in here. There's a wire cage in here, and you can see the line of the form here. So these are two-piece forms. The concrete's placed into the bottom half of this, and this is at about a 22-inch slump flow as well. Very high viscosity mix. It might take 3 days for it to pull the slump cone and get to the 22, 23-inch slump flow. Aggregate content, coarse aggregate content stays fairly high in these mixes, but you pour the bottom half, they put the top half, bolt it together, and then it goes to a spinner. And this is the first video, so again, don't have your sound too loud, or it may get a little loud for you. Never seen a spun pole plant, it's worth a trip. This is a video inside a mixer, and this is again about a 23, maybe a little higher slump flow, not being consolidated, but just wanted to point something out since we're all very technical people and we like technical stuff. So I'll video, and I just want you to notice that this is a pan mixer, and right next to the hub doesn't get mixed. So very fluid concrete, very nice looking SCC. Next to the hub, not mixing. They need to fix their wiper blades here. So when this goes in the form, the vibration is going to help take care of that. Now, I don't recommend vibrating to cover up for inefficiencies in your mixer, but it's just something I wanted to point out here. Yes, this is a very cool video, and it is in slow-mo. I'm not going to show the whole thing, but you get the... This is one of those architectural panels that we talked about, and you can see the brick insert here. And this concrete, again, is less than 24, probably in the 22 to 24 range. And you're going to see what might be considered bad vibration practices. So notice the sound of the vibrator. I'll talk about this. So they're gonna put concrete on top of this. That's why they're screeding it down. It's going to get a great concrete backing. But they're vibrating this. They want to make sure that the paste, some of the mortar, the paste gets in those joints. And I'm not going to show the whole thing. I do a lot of slow motion videos, but you can see the viscosity of this mix is pretty high because they're clinging to the screed board they're using. Okay, this is a segment for an air traffic control tower and in a precast plant. And so these segments are going to be placed, and I have a video here coming up, and you'll see that there's a lot of rebar in the corners here. And this is about 800 pounds of powder in this mix, and the concrete that you're going to see placed, which is, I apologize, the next video is not great. It's about a 25-inch slump flow, and again, about 800 pounds of powder in this mix. And they do vibrate it. So not the greatest video. Don't even think you can see the vibrators on the form, but this is form-mounted external vibration during the placement. Really pixelated here, I apologize, not a very good video. vibration. Again, note the sound of the vibration. I think this is a double T. Again, these last few videos aren't great. Shot with a cell phone and emailed to me. By the way, there's 3 different admixture companies products in these videos. They're not all ours. There's 2 other admixture, so it's not just my admixtures that people are vibrating. Really flowable SCC. And this is just what it looks like. They actually, so this company, the foreman on the crew decides if they're going to vibrate a load or not vibrate a load. They tend to vibrate most of the loads. If they have one that's approaching the 30-inch slump flow, they're probably not going to vibrate it. So you're going to see a piece of rebar sticking out that.
Terry, can we finish it in a minute? Terry, can we finish it? It is 5 minutes after 6. Can we wrap it up?
Yes, sir. I think this is my last video. Now I got a couple of slides and I'll be done.
Oh, thank you, sir. Thank you.
So this is vibrated. This section is not. You really don't see a difference in how. Okay, so tank ring vibrators. This is again. This top part is out of 309. So, so essentially, it's a rapid motion that's transmitted to the freshly placed concrete, described in terms of frequency, number of oscillations or cycles per unit of time, and amplitude, the deviation from the point of rest. So higher frequency tends to move the paste, brings aggregates with it. Okay, when listening to the vibrator, the higher the pitch, it's the higher the frequency. Okay, so those high whine sounds tend to be higher frequency vibration. When you're vibrating SCC, that's what you want. The amplitude tends to move the aggregate, and for SCC mixes, you have a high amplitude, low frequency vibrator, you're probably going to have issues with segregating the mix. Okay, that's a real quick lesson on vibration. This is an example of frequency and amplitude. Okay, so hopefully you get this.
That some of you were on, and thanks to Bernie, by the way, for
amplitude. Now the frequency is increasing and the amplitude is decreasing. So he's hitting it really, really hard, really far apart, and then he's hitting it not as hard and closer together. So this is actually a test that this precast company does to determine if the mix is good, because they're going to vibrate it. I thought it was interesting.
Thank you, Terry. Thank you, Terry. Can we conclude this?
Yep, my last slide. So,
thank you so
it's
much.
concrete, and it's okay to vibrate it. And these are the reasons why they vibrate. And I'm done, Shelly.
Yes, yes. Thank you.